As another example, let's consider x of t equals 3 times the cosine of pi t plus 3 pi over 4. Now this corresponds to the circular model, where we have a point moving around a circle of radius 3 at pi radians per second. Let's assume that t is in seconds. The units of t are going to be dictated by the units of omega, the units of k and gamma and mass m. But in any case, we're going to have a reference point. Starts at angular position (3 pi over 4) when t equals 0. So angular position 3 pi over 4 would be here. Here's the angle, 3 pi over 4, and moves then at pi radians per second, moving around the circle. Now the 3 cosine of pi t plus 3 pi over 4 indicates that our oscillator follows this motion on the x-axis. So here's our oscillator. There's our oscillator at the initial instant. As the point continues to move around the reference circle, the oscillator will shadow its motion, moving over to here as the point moves from here to here. Then as the point moves through the third and fourth quadrant, the oscillator will turn around and move in the positive x direction, eventually reaching this point before turning around as the oscillator then moves upward and to the left and back and forth, so that the oscillation is between x equals -3 and x equals 3. The amplitude is 3 and the graph of the x-coordinate versus time will look something like this. The x-coordinate when we start is over here closer to -3 than it is to 0, but it's negative, so that the initial x value, if -3 is here and +3 is here, the initial x value is probably along here. So this would correspond to the initial point at t equals 0. Then the x position goes down to -3 before turning around, starting back up toward +3. So what happens? The oscillator moves down to -3, corresponding to the point at which the reference circle, the reference point reaches here, and then turns around and moves up, eventually reaching +3 before coming back down and continuing its oscillation. In this case, there's no end to the oscillation. The oscillation continues on the graph looking like this and the oscillation looking like this. An example could be an ideal pendulum or mass on a spring.